In this video, we're going to talk about solving a system of equations algebraically. I'm going to break this target 8 up into two different videos, one video for the substitution method and another for the elimination method. They are both algebraic methods, just one is different than the other. So that's our objectives for today. And in the first objective, solving systems using substitution, we've got a step-by-step guide, and we'll talk about that. So first, the goal of substitution is to get one equation into the other one, leaving only one variable left to solve for. So that first step is going to be to isolate one of the two variables in one of the equations. You can choose to isolate either variable, but you should try to find the variable that will be the easiest to isolate. So, for example, when you're solving a system like the one here, you're looking at the 5x, the negative 3y, the 2x, and the y. And between all of those, the y in the second equation would be the easiest to isolate, to get by itself. So I would take that second equation and rewrite it by subtracting 2x to both sides. So y equals 7 minus 2x, or negative 2x plus 7, whatever you're more comfortable with. So since we've been graphing lately, we probably are a little more comfortable with that version. But step 2 would then be to substitute the expression for the isolated variable into the other equation and then solve that. Okay, that's kind of confusing. So if we take 5x minus 3y equals 23, we are going to take what we isolated, the negative 2x plus 7, and plug that into the first equation's y value. So plug it in for y. What that looks like is this. 5 times x minus 3 times, instead of y, replace or substitute, that's where it gets its name from, substitute the negative 2x plus 7 in for y. So it will still equal 23. So again, all we did was isolate the y from the second equation and take what it equals. Take the y that equals negative 2x plus 7 and put that into the other equation for y. From here, it's just distribute, combine like terms, and solve for x. So distribute our negative 3. We'll have 5x. Negative 3 times negative 2x is positive 6x. Negative 3 times positive 7 is negative 21. We'll combine our like terms of 5x and 6x. Get 11x minus 21 equals 23. And then start moving things to the other side of the equation. Add 21 to both sides, and we get 11x equals 44. And last step, divide by 11, and x equals 4. All right, so since we got a number x equals 4, this is clearly going to be an answer. Two lines that intersect. Thinking about our learning target 7, these are going to represent two lines that are intersecting, so our solution is going to be an ordered pair. And we just found the x value of that ordered pair. So we still need the y that goes with it. So our final step, step 3, is to substitute the value, the x equals 4, that we got in step 2, into either of the original equations and solve for the y. So we'll just take, for example, the original equation said 2x plus y equals 7. 2x plus y equals 7. Now that we know x is 4, we can take 2 times x plus y equals 7, take that 4, and substitute or replace it, and then solve for y. Subtract 8 to both sides. Y is negative 1. So that finishes our ordered pair. The answer is 4, negative 1. Had we graphed these two lines, they would have crossed at 4, negative 1. All right, just to prove it, I'm going to take the other equation, 5x minus 3y equals 23. And I'm going to replace the x in that equation with 4 and solve for it as well, just to make sure that I also get y value negative 1 here. 20 minus 3y equals 23. subtract the 20 from both sides, and negative 3y equals, let's see, 23 minus 20 would be 3. Divide by negative 3, and our y value becomes 3 divided by negative 3, negative 1 there as well. Further proving you could have substituted the value from step 2 into either equation, and it would have given you y equals negative 1. So that's substitution for one problem. In class, we actually looked at not all 12 of these. We looked at these 12 and then decided which one or two do we need to try, and we tried a few. So if you need more help with substitution, just come to tutoring and we'll work on it together. But our final answer for that problem is 4, negative 1.